Hello, Victor. This is Jasmine. So I'm just going to make you a quick video to go over a few of your problems. Starting with number 17, 125 x squared minus 80. All right, so the first thing you want to do is see if there is a greatest common factor that simplifies the problem into something that's more workable. So we can definitely divide both of these numbers by 5. And so we factor out a 5. We're going to go ahead and put it on the outside. That leaves us with 25 x squared minus 16. Now, if you notice here, we have a perfect square, another perfect square, a perfect square, and a negative sign denoting a difference. So with a perfect square in the front and the back and no middle term, so no b term, this is known as difference of squares. And so the rule for difference of squares, which you should definitely memorize, it'll save you a lot of trouble, is that if we have a squared minus b squared, that factors to a plus b times a minus b. And so the goal is to simplify the problem so that we can more easily factor it based on this rule. So our a term here is equal to 5x. And so to find the a term, we just take the square root of the a squared. So square root of 25 is 5, and the square root of x squared is x. Our b term is 4. So we take the square root of 16 to get 4. And now we just have to put it into our factored form. So we have a plus b, and then a minus b. And then don't forget we factored out that 5, so that has to stay in our final answer. Okay? And so that is the answer for number 17. For number 18, you had 18x squared plus 12x plus 2. Again, we want to see if we can find a greatest common factor. And we can definitely divide everything here by 2. Now, you don't have to divide this one by 2, but it definitely simplifies the problem, and so that's what we want to look for. Okay, anything to make this easier, right? So we factor out a 2, and that leaves us with 9x squared plus 6x plus 1. Now, it still looks a little crazy because our standard form for polynomial is ax squared plus bx plus c, where this is our quadratic term, the b term is our linear term, and our c term is our constant. We like our a term to be a positive 1 when we factor. Those are kind of, that's how we learn the factor rules, when a is equal to positive 1. The way that we do that is by rewriting this problem. And this is a really neat trick that works all the time. We can take this 9, multiply it times 1. So we took the a term, the a coefficient, and we multiplied it by, I'll make this up here, multiplied it by our c term. That's the first step. Now we're going to rewrite the problem without it. Our b term stays the same. Now we're going to do what we would normally do. We're going to look for the factors of 9 that when added together give us our b term, so give us 6. And if you notice, our sign in the right before our c term is positive, so we know that our signs have to be the same. So they either have to be positive, positive, or negative, negative, because our sign is positive. Now our b term is also positive. That confirms that we're going to have a positive, positive. So we're going to do positive, positive, and then we're going to find factors of 9 that add up to 6, so we have 3 and 3. So we can go ahead and put in our x's, and we're going to do 3 and 3. Now because these are the same, we can rewrite this as 2 times x plus 3 squared. Now, remember in the very beginning, we multiplied this 9. So we need to redistribute that 9 out. And the way we do that is by dividing this factored term by the same number that we multiplied it with in the beginning. And so once we simplify that, we get 1/3. So this becomes 2 times x plus 1/3 squared. Now traditionally you won't have a fraction there, and so the way that you fix that is by taking the denominator and putting it in front of the x, and that gives us a final answer of 2 times 3x plus 1 squared. Okay. We're going to skip 19 so that this isn't a super long video, and I'll do that one separately. But for number 20, we had 3r cubed minus 81. And you guessed it, the first thing we're going to do is we're going to factor out the greatest common factor. So we're going to divide the whole thing by 3. And so we're going to put the 3 on the outside, and we're left with r cubed minus 27. Now, notice here, we have a perfect cube in the front and a perfect cube in the back, and no middle term. So this is going to be difference of cubes. So we're going to keep the 3, and difference of cubes, just like difference of squares, has its own formula. So for difference of cubes, we're going to remember SOAP. And the acronym stands for same, opposite, and always plus. Okay, so we're going to go ahead and set that up. So we're going to have one set here. We're going to have another set there. I'm just going to erase this right there so it's not in the way. Okay. So we're going to have the same sign, so same sign, opposite sign, and always plus. Now let's go look at our factors. So this is going from a cubed minus b cubed becomes a squared. Oh, I'm sorry, hold on. That's the second part, I'm getting a little ahead of myself. All right. So this becomes the same, so a minus b times a squared, which I started to write the first time, but it's right here, a squared plus ab plus b squared. Okay, and if this sign were opposite, so if this were a positive sign here, then it would just be same sign, opposite sign, and then always plus. Okay? So let's go back to our problem. So our a term is going to be the cubed root of r cubed, so just r, and our b term is going to be the cubed root of 27, which is 3. Oops, there we go. 3. All right, so we're going to do just like we have up top. So r minus 3, and then we're going to do r squared plus ab, so 3r plus b squared, 9. So that is your final answer. Awesome.